So since there's no quotient rule, we changed it to a product rule, and it gave us 1/2 antiderivative of 4/3 cotangent of x cosecant squared of x dx. And that is our first step in this, and yeah.
Okay, so in our next step, we set u equal to the exponent, and we find the derivative of u. Which equals to -3 cosecant squared x. And then we isolate du. And since we don't have cosecant squared x by itself, we divide by -3. So we get du over -3 equals cosecant squared x dx.
Now that we have u, we substitute it into the equation as such, set the exponent equal to u, and comparing this to what we got for the derivative of u, we set cosecant squared of x dx to negative dx over 3, and we move out to 3, and we get -1/6 antiderivative for u du. Now we're ready to actually solve it. So it's a constant multiple, so we just put it in, and then we repeat the term and divide it by natural log of the base, and let's not forget plus c, and then we multiply it once more and substitute 3 times cotangent of x for u, and we get -4 to the power of 3 times cotangent of x, the whole thing divided by 6 times natural log of 4 plus c. QED.
So our next problem is f of x equals x squared plus 6x minus 3 over the interval of -2, 3. Since the function is polynomial and we already know that the first two conditions is continuous and differentiable, we're moving straight to the third condition, which is f of a equals f of b. Since the third condition
Is what's left.
is what's left, we factor -2 into f of x, and that gives us f of -2 equals -2 squared plus 6 times -2 minus 3, and that equals 2. So the -2 squared is +4, 6 times -2 is -12, -12 minus 3 is -15, and then -15 plus 4 is -11.
The second part of the third condition, and we substitute f of b for f of 3. So it goes so this gives us 9, this gives us 18 minus 3, which gives us 15, which equals to 24. So the third condition, the function fails the third condition, and so therefore there is no conclusion.
And now we move on to mean value theorem, which means we have to find f prime of c, which will be f of a minus f of b, or vice versa works as long as you keep it the same down here, -2 minus 3, which this equals -11 minus 24 over -5, and negatives cancel out at the end because it'll give us -35 over -5, and the end equals 7. Then we substitute f prime of c for the derivative of the original function, which is 2x plus 6. We change it for a c, and now it's 2c plus 6 equals that number. So 7, and now it's just algebra or basic arithmetic. C equals positive 1/2. 1/2.